Now that you're familiar with your trig functions, we're going to talk about trig ratios that we can use to solve triangles. There'll be two separate videos. The first video, as you can see that's marked here, it's going to be finding a missing side length. The second video is going to be solving a missing angle. So when we want to solve a missing side length, we're going to try to set up a trig ratio and then use our calculator to assist us in solving for x. If you want to try using the calculator, I would suggest that you pause the video or stop the video and get a calculator and then restart it. I will be using a calculator, but all I really want to do is just kind of show you two examples. It should be a fairly short video. So I want to solve for x on each of these. So on the first one, I'm given an angle, I'm given a side, and I'm given an unknown side. So typically with right triangles, we try to use Pythagorean's theorem. But with Pythagorean's theorem, we have to know at least two sides. And looking here at example A, I see I only have one side. So rather than use Pythagorean's theorem, I'm going to say that I know an angle, that angle's adjacent side, and that angle's hypotenuse. So if I look at SOHCAHTOA, I see I could use cosine to set up an equation. I could say that cosine of my given angle, which this time I know it, it's 35, is equal to my adjacent over my hypotenuse. Well, I can solve for x here by multiplying both sides by 7. When I do, these 7's cross out, and I can then go to my calculator. So here would be my exact form, but I can use my calculator to approximate this. I make sure my calculator is in degrees, and that's something that I can show you in class. Most calculators are already in degrees. It's when we start changing to radians that we'll start looking at how to do that. So for now, your calculator is more than likely in the form you need it to be in, so I would not worry too much about that statement I just made. But I make sure it's in degrees, and I go ahead and I say 7 times cosine of 35. I can either do it in one step, or I can first figure out what cosine of 35 is. If I want to do that first, all I do on my calculator is hit cosine 35 equals. Some calculators, you should hit the 35 and then hit the cosine button. But you should get 0.819. If you're not, like I said, we should talk about that in class. Multiplying that by 7, I would get 0.5733 is equivalent to my missing side. And notice now, if I wanted to find that other missing side as well, I could either use Pythagorean's theorem, or I could just use another trig function. Looking at one more example, example B, I'm going to look at the same thing. I'm told an angle, and I see that I'm told the side across from it, the opposite. And I'm asking to find my hypotenuse, and I know it's my hypotenuse because it's across from my right angle. So looking at SOHCAHTOA, it looks like I should go ahead and say sine of my given angle, which is 21, is equal to opposite over hypotenuse. So remember, I cannot solve a function if I have a variable in the denominator. We looked at this previously when talking about logarithmic functions. So I have to get this x out of the denominator. I can do that by first multiplying both sides by x. They cancel here, giving me x sine of 21 equals 9. So I still can't solve this. I still have to do something else to get x by itself, but at least it's not in the denominator. So I can divide both sides by sine of 21. I cancel here and I get x equals, here's my exact form. I put it into my calculator, 9 divided by sine 21, and I get 25.114. And unless told otherwise, we will always round to 3 decimal places. Since once you hit AP Calculus, that is what we will do, since that is what is required of you on the AP Calc exam.